Praise the Lord. Hi friends, welcome back to this YouTube classes on the chapter of mathematical induction. Dear friends, in the previous session we have seen the concept of mathematical induction and also we have worked some 3 important questions and we are going to continue with the next problem. Okay, so the problem is quite clear. As we all know, the given statement I have taken it as P of n. Is it clear? So we shall start with the first step, which is to prove P of 1 is true. So the first step of us is to prove P of 1 is true. Okay, so let us consider the LHS. The LHS, as we all know, let us consider the first term, which is nothing but 1. Okay, now moving on to our RHS. So RHS is nothing but, so put n is equal to 1 in the RHS of the given statement. So that is nothing but 3 power 1 minus 1 divided by 2. See what happens. So 3 power 1 is 3, 3 minus 1 is 2. So 2 by 2, that is nothing but 1. Hence, LHS is equal to RHS, therefore P of 1 is true. We have done with step 1. Let's go on to the step 2. So what is our step 2? We know that it's a step of assumption. We will assume that P of m is true. So how do we prove this step? Just put n is equal to m in the given statement. That is, I can take 1 plus 3 square, moving on up to 3 power m minus 1. This is nothing but 3 power of m minus 1. Hence it is 3 power of m minus 1 divided by 2. Isn't it? So put wherever you have n, replace it to m. Okay, so this will give my step 2. We know this, we will consider it as equation star. Okay, we have nothing to do with step 2. Let's go on to step 3. And we know the step 3 is nothing but to prove P of m plus 1 is true. Okay, as we have done in the previous cases, we are going to add some term. What is the term? Is nothing but adding. So the last term in the LHS is 3 power m minus 1. You have to take the next term. So actually it would be nothing but 3 power m. M minus 1 next term is nothing but m. So adding 3 power m. Remember, it's not 3m. It is 3 power m on both sides of equation star. Isn't it? On both sides of equation star. See what happens. So therefore, you have 1 plus 3 square, so on. The last term you are left over with 3 power m minus 1. To this term, I am adding 3 power m. So this will finish the work for LHS. That is equal to 3 power m minus of 1 divided by 2 plus 3 power m. So I have added on LHS. I am adding to RHS also. And now let us take the LCM. If you take the LCM, it will be 2. So you will be getting 3 power m minus 1 plus 2 times 3 power m it is. Okay, so this is nothing but, if you look here, so this is 1 times 3 power m and this is 2 times 3 power m. If you add up, you will get 3 times 3 power m minus 1 divided by 2. Okay, so this is nothing but, we know using the law, a power of m into a power of n is a power of m plus n. So that is nothing but a power of m plus 1 minus of 1 divided by 2. Now you can check here, this is what actually I wanted, because in place of n in the RHS, I have replaced with m plus 1. So that is enough for me to say P of m plus 1 is true, isn't it? So P of m plus 1 is true. Once this step is cleared, we are going to write the conclusion. So what is the general conclusion we write? From 1, 2 and 3, we say P of n is true for all n belongs to n. Okay, hence the proof. So this is the steps we are going to use to prove the given statement by the principle of mathematical induction. Okay, hope this was a very simple question. Let's move on to the next one. Now moving on to the next question. Question is quite clear. P of n is equal to 1 square. Read it carefully. It is 3 square, 5 square. That is sum of all odd terms. The last term is 2n minus 1 whole square. you have to show it is equal to n into 2n minus 1 into 2n plus 1 by 3. Step 1 is quite clear. You have to prove P of 1 is true. So yes, let us consider the LHS to prove my P of 1. LHS, as we all know, first term is actually 1 square. 1 square is nothing but 1. Okay. Now let me consider my RHS. So RHS is nothing but, put n is equal to 1 in the RHS of the term. So 2 into 1 is actually 2 minus 1, and 2 into 1 is 2 plus 1 divided by 3. Okay, so this is nothing but 1, 2 minus 1 is 1, 2 plus 1 is 3 divided by 3. Now 3 and 3 gets cancels, 1 into 1 is 1. So you can see here what we can say, LHS is equal to RHS, therefore P of 1 is true. Once we have done with step 1, let's move on to the step 2. So for the step 2, let us assume P of m is true. Write down the same statement in terms of m. So it is 1 square plus 3 square plus 5 square, moving on up to 2m minus 1 whole square. So this will be equal to m into 2m minus 1 into 2m plus 1 divided by 3. Okay, so you can take this as equation star. Okay, that's it we have with step 2. Let's move on to step 3. So to prove P of m plus 1 is true, we're going to add the term. So actually what is that term you're going to add is, if you have any confusion in what is the term you're going to add, just in the last term wherever you have m, put m plus 1. So it is 2 into m plus 1 minus 1 whole square. Okay, so this is nothing but, now if you multiply this, you will get 2 into m is 2m plus 2 minus 1. Actually 2 minus 1 is 1. So actually you are going to add 2m plus 1 whole square on both sides of equation star. Okay, is it clear? Please understand the term what you're going to add. Both sides of, let me say, equation star. Okay, see what happens. Therefore, I can write 1 square plus 3 square, that is enough. The term you already have is 2m minus 1 whole square. To this term I am going to add 2m plus 1 whole square. Okay, so LHS is quite clear. Moving on to our RHS. What I already have is, m into 2m minus 1 into 2m plus 1 divided by 3. To this term I am going to add 2m plus 1 whole square. Okay, so what happens is, so this would be nothing but, in both the terms I can take 2m plus 1 term common. So if you take away the term common, in the first term I am left over with m into 2m minus 1 divided by 3 plus here, from here I'll get 2m plus 1. Okay, so this is nothing but 2m plus 1 into, let me take the LCM. So this will be m into 2m minus 1 plus 3 into 2m plus 1 divided by 3, isn't it? So this is nothing but 2m plus 1, the outside term is clear, you have nothing to do with this. This is nothing but, now multiply the term, you'll get 2m into m is 2m square minus m into 1 is m plus 3 2s are, it is 6m plus 3 1s are 3 divided by 3 is the term. Okay, so this is nothing but, I have 2m plus 1 into, here I will be getting 2m square plus 5m plus 3 divided by 3. Okay, from here the steps is quite clear. Now it's up to you. I'm going to leave this step as a factorization term. You can factorize by yourself. Okay, so if you factorize this, the terms you are going to get will be m plus 1 into 2m plus 3. Okay, factorize this using factorization, you will get it divided by 3. Okay, now see how I'm going to rewrite this term as, so this is nothing but, keep this term m plus 1 outside as the first term, because in the RHS the first term is n, so in place of n I have m plus 1. Now this 2m plus 1, I'm going to write it as 2 times m plus 1 minus 1. If you want, you can check it. So this will be 2m plus 2 minus 1. So that will be 2m plus 1. Again, this 2m plus 3, I'm going to write it as 2 times m plus 1 plus 1, because 2m plus 2 plus 1 is 2m plus 3 divided by 3. So if you have understood this step, then you will not going to have any doubt here. Okay, so this will clear all the terms from the RHS. If you want, you can check. In terms of n, I have 2 times n minus 1 is 2 times m plus 1 minus 1. Similarly, 2n plus 1 is 2 times m plus 1 plus 1 divided by 3. Okay, so this proves our step 3. Therefore, P of m plus 1 is true. So you can finally see here, therefore P of m plus 1 will be true. So from 1, 2 and 3, you need not write every time conclusion. It is understood. So from 1, 2 and 3, hence P of n is true for all n belongs to n. And that will be the proof for this question. Okay, the step is almost exactly same for all the problems. Only thing is, depending upon the problem, the step 3 will change. Okay, you might not say that all the problems are in same method. There are variety of problems even on the process of mathematical induction. Okay, so we are going to see the variety of problem starting with this video itself. Okay, fine, let's move on to the next question. So here comes quite a special type of problems. The term given, the first term, you can take the given statement as P of n. Okay, so let us consider the given statement as P of n. You have to prove this statement. Okay, let us start with the regular process. First step 1 is to prove P of 1 is true. Okay, now LHS. What is LHS? It's quite clear. First term is 1. That's it. Nothing to do with this. Now moving on to RHS. So what is RHS? You have 2n divided by n plus 1. That is actually 2 into 1 divided by 1 plus 1, because in place of n, I've substituted 1. So this is nothing but 2 into 1 is 2 divided by 1 plus 1 is also 2, and 2 by 2 will give me 1. You can see here LHS and RHS both are same. Therefore, P of 1 is true. So this completes the step 1. Let's move on to the step 2. So here comes the step 2 to assume P of m is true. So moving on in the same ways, I can write 1 plus 1 divided by 1 plus 2. It's enough if you write 2 terms. So on up to 1 divided by 1 plus 2 plus moving on up to m. Remember, replace n by m. You will get the second step. So that is nothing but 2m divided by m plus 1. Okay, so this I'm going to treat it as my equation star. Okay, so this completes my step 2. Let's go on to the most important step, which is step 3. So be careful in this step now. So we know, since each term is an addition, for the step 3, which is to prove P of m plus 1 is true, we're going to add a term. So what is the term you're going to add is, please be very careful. So all are reciprocal functions. So I should also add a reciprocal function. How? The function would be 1 plus 2 plus so on up to m, and the next term is m plus 1. Actually, this is the term I should add. Are you following? So the last term in the LHS is 1 to m. I have to take the next term, which is m plus 1. Okay, let us add this term on both sides of equation star. And let us see what happens. Please be careful in every term I am writing. So LHS would be 1, okay, plus 1 divided by 1 plus 2, okay, plus going on, I have 1 divided by 1 plus 2 up to m. To this term, I am adding this term. What? It is 1 divided by 1 plus 2 plus up to m plus m plus 1. Remember, this is just my LHS. Okay, so this will be equal to, please be careful, this will be equal to, what is the term in RHS? It is 2m divided by m plus 1. Okay, plus again add this term, which is 1 divided by 1 plus 2 plus so on. Let me write the last term as it is, which is m plus 1. So I did not write m here. This would already be understood. Okay, so this is nothing but, actually I'll get 2m divided by m plus 1 plus 1 divided by, this looks like, please be careful, I'm going to write it in a different color for you to understand. So summation of 1 plus 2 plus last term is m plus 1. This is actually summation of m plus 1. This is actually the, I told you we're going to use the formula. This is just like summation n. What is summation n formula? So sigma n is n into n plus 1 divided by 2, isn't it? So we're going to use that formula. This is nothing but, don't change this term, keep it as it is, 2m divided by m plus 1 plus 1 divided by, now this complete looks like n, sorry. So it is n into n plus 1, that is m plus 1 plus 1 divided by 2. Are you following? Now see what happens. So this is nothing but 2m divided by m plus 1, okay, plus, now this 2 goes to the numerator because it is a divided by b by c, you will get ac by b. So this is nothing but 2 divided by m plus 1 into m plus 1 plus 1. So 1 plus 1 will give you m plus 2, okay. So we have to simplify now. In both the terms, in the numerator I have 2 common, in the denominator I have m plus 1 common. See what is left over. From the first term I have m left over, and from the second term I have 1 divided by m plus 2 left over. Okay, let us simplify this. So this will be, you have 2 divided by m plus 1 into, if you cross multiply you will get m into m plus 2 is m into m square, plus m into 2 is 2m plus 1 divided by m plus 2. Okay, now I'm going to leave the next step for you as a homework. You can try it because it's quite simple. The numerator I'm going to write it as m plus 1 whole square, because if you expand this you are going to get, while practicing, only when you can practice you will come to know what is this. Otherwise you factorize this, you will get both the terms as m plus 1 into m plus 1, and the denominator is nothing but m plus 2. Okay, so your one term of m plus 1 gets cancels, and see what happens. You are left over with, numerator is 2 and one term is left over which is m plus 1 divided by, denominator is actually m plus 2. I'm going to write m plus 2 as m plus 1 plus 1. The reason is, you can check this with the LHS in the general term. So in place of n I have m plus 1, therefore I can write p of m plus 1 is true, which completes the step 3, and finally write the conclusion also. So once you write the final conclusion, that will complete the solution. Please make sure, dear students, you write the conclusion, because for a 5-mark question, if you don't write the conclusion, you are definitely going to miss 1 mark, right? Hope you are not going to make that mistake. Now, believing that, let's go on to the question number 4 for the session. So dear students, I told you there are variety of questions in mathematical induction. So here comes another different question. Okay, P of n is given in this way. Let us directly go on to the process. We can easily prove it. So step 1 is very simple. To prove P of 1 is true. So what is LHS? What is the first term? LHS first term is 1 by 2. Okay, so keep it as it is. Now what happens to RHS? So RHS is nothing but, in the right hand side put n is equal to 1. So it is 1 minus 1 divided by, it is actually 2 power 1. 2 power 1 is nothing but 2 only. So this is nothing but, what is 1 minus half? It is quite clear, it is half, isn't it? In complete 1, if you take away half, it is half. So it's very simple here. LHS is equal to RHS. Therefore P of 1 is true. Though the question looks quite different, the procedure is exactly the same. So once the first step is clear, we're going to see one of the simple steps, which is the step 2. We're going to assume P of m plus 1 is true. How you're going to assume? Just replace this given statement, wherever you have n, replace it by m. So it is 1 by 2 plus 1 by 4 plus 1 by 8, moving on such that 1 divided by 2 power m. This is LHS. This is nothing but 1 minus 1 divided by 2 power m. Okay, this is what we are going to assume and take it as equation star, and we know we have done with step 2. And the next step is step 3. Well, small correction, dear students. The second step was assume P of m is true, not P of m plus 1. Kindly, I hope you might have you might have had a doubt and you might have changed it. Excuse me. This is P of m is true, and third step would be to prove P of m plus 1 is true. Okay, so please make that correction. So that is quite clear. Now next step is to prove P of m plus 1 is true, we are going to add the term. That is quite clear. So that is nothing. What is the term you are going to add is nothing but 1 divided by, look at the last term. The last term in LHS is 2 power m. I told you wherever you have m, put m plus 1. So that is the term we are going to add. So adding 1 divided by 2 power of m plus 1 on both sides of equation star. So see what happens if you add it. It's a quite clear, simple statement. You have 1 divided by 2 plus 1 divided by 4, so on. What is the term you actually had there? I have 1 divided by 2 power m. To this term I am going to add 1 divided by 2 power m plus 1. So my LHS process is over. This is nothing but 1 minus 1 divided by 2 power m, okay, plus 1 divided by 2 power m plus 1. Okay, now see how I'm going to make the correction. This is nothing but 1 divided by, let me take it as 1 divided by 2 power m, okay, plus 1 divided by, I can write it as 2 into 2 power m, because we know 2 power m I've kept inside and this 2 power 1 I kept outside. Okay, actually now look here, see how I'm going to write. So this is 1 minus, let me write it as 1 divided by 2 power m, okay, plus half into 1 divided by 2 power m. Are you following? I am writing it in such a way that two term looks alike. So this is nothing but 1, look here, this is full term. It is like minus x plus half x, nothing but half x minus 1. So it will be nothing but minus half x, isn't it? 1 minus half is nothing but half, isn't it? So minus half. So it is minus of half into the term which is 2 power of m. Are you following? If you have any confusion, take this as p and this will be p. So it is p minus p plus p by 2. It will be, you will get p by 2, isn't it? That is half of p. Now I'm going to write it to the other way. So this is nothing but 1 minus 1 divided by 2 into 2 power m is 2 power of m plus 1. If you want, you can check there. The RHS in the general term is 1 minus 1 by 2 power n. In place of n, I have got m plus 1. So this concludes my step 3. Therefore, P of m plus 1 is true can be easily written. So once you have written the third step is clear, last you are just left over with the conclusion. So from a general and a regular conclusion, this is from 1, 2 and 3 we have P of n is true for all n belongs to n. This will conclude the solution for question number 4. Okay? Yeah, hope you don't have any doubts in this. If you can practice this, these type of questions are very simple. They may look different, but actually they are simple questions. Okay, now let's move on to another design of question, which would be in question number 5. So dear students, here comes a different type of question. Please be very, very, very careful, because there are chances that the student will read it as 1 divided by 2.5 and 1 divided by 5.8. No. This is actually 1 divided by 2 into 5. This is rather multiplication. So 2 into 5, 5 into 8, 8 into 11, similarly. Okay. So this is the term I'm going to prove by the principle of mathematical induction as regular. Step 1, to prove P of 1 is true. So how we are going to prove P of 1 is true? Let me consider my LHS. So LHS is 1 divided by 2 into 5. So this is nothing but 1 divided by, I told you this is not 2.5, it is 2 into 5. 5 2s are 10. So it is 1 by 10. Let us check for RHS. RHS is nothing but, put n is equal to 1. So 1 divided by 6 into 1. So it is 6 plus 4. You can see quite clear It is 1 divided by 6 plus 4, that is 10. So you can easily write. So P of LHS is equal to RHS, hence P of 1 is true. So we have done with step 1. Let's move on to the step 2. So we know step 2, it is to assume that P of M is true for all M belongs to N. Okay. Now adding, please be careful in this step, because if you know how to add the term, then you have simplification left over. So wherever you have N here, okay, right, sorry, this is in step 3. Just let's write down the given statement in terms of N. That is only the process here. So what is the step? Let me write 1 divided by 2 into 5 plus 1 divided by 5 into 8 plus 1 divided by 8 into 11. Moving on. Finally, it is 1 divided by 3m minus 1 into 3m plus 2. Okay. So this is the last term in LHS. This is equal to m divided by 6m plus 4. Okay. So this will be my equation star. Okay. So this has completed my step 2. Let's go on to the step 3. So the step 3 is to prove P of M plus 1 is true. Please be careful. Adding 1 divided by wherever you have M, put M plus 1. So 3 into M plus 1 minus 1 into 3 into M plus 1 plus 2. So this is the term you will be adding. That is nothing but see the term you're going to add. So it is 3 into M is 3M. What is 3 into 1? So it is 3 minus 1. 3 into 1 is 3. 3 minus 1 is plus 2. Similarly, 3m will be as it is. 3 plus 1 is 3. 3 plus 2 will be 5. So this is the term we will add. Please be careful. We will be adding 1 divided by 3m plus 2 into 3m plus 5 on both sides of equation star. So let us see what happens if you add. I have 1 divided by 2 into 5 plus 1 divided by 5 into 8, so on. What is the, now instead of writing this step, you can directly write this step. Okay, it is understood if you just write 1 divided by 3m plus 2 into 3m plus 5. Again I am telling you, if you don't write the previous term, it is understood this term will be the previous term. Okay, so this is nothing but I have m divided by 6m plus 4, isn't it? This 6m plus 4, in this term if I take 2 common, I will get 2 3s are 6. So 6m plus 2 2s are 4. Are you following? Why I took common is I can take, in the next step it will be useful for me. So it is 1 divided by 3m plus 2 into 3m plus 5. So now let us simplify now. What can you do it is, let me take the term common. What is the term common? The term common is in the denominator. It is 3m plus 2. So what is left over? In the first term you are left over with m by 2. In the second term you are left over with 1 divided by 3m plus 5. Isn't it? Okay. So this is nothing but 1 divided by 3m plus 2 into, if you take the LCM, you will have 2 into 3m plus 5, isn't it? So now let us cross multiply because you have taken the LCM now. 3m into m is 3m square, okay, plus 5 into m is 5m plus 2 into 1 is 2. Hope you don't have any confusions here. To see how I'm going to make some changes here. So it's 1 divided by, since this term is multiplied in the denominator, let me bring it outside. So since 2 is out, written this 2 here, what is term I already have? 3m plus 2. Okay, here denominator, let me replace it as 3m plus 5. Now I will leave this for you as a homework. You can factorize this using factorization. So if you factorize the numerator, it's up to you. I will leave it for you. You will get m plus 1 into 3m plus 2. So this is the term you are going to get after factorization. So what happens now is you have 3m plus 2 in the denominator, 3m plus 2 in the numerator. It will get cancelled. So you are left over with I have m plus 1, okay, divided by 2 into 3m plus 5. So let me multiply this. So this will be nothing but 2 3s are 6m plus 5 2s are 10. Okay, let me rewrite this to match with this term. Okay, so this is nothing but m plus 1 whole divided by, it should be 6 into m plus 1, remember. Okay, so what will happen to 6 into m plus 1? So it is 6m plus 6. So how much is left over out of 10? 6 is outside, 4 is left over. So you can compare this with the general term in the RHS. Both are actually same, only n is replaced by m plus 1. So once this is clear, we can easily write P of m plus 1 is true and write the conclusion that P of n is true for all n belongs to n, isn't it? So if you can finally write the conclusion P of m plus 1 is true and the final conclusion, so this will complete the complete solution for question number 5. Okay. So let us take similar, there is a similar question, one more. Let us take that question also now. Okay students, so let's take one last question before we complete this solution. This is actually similar to the previous question. Okay, 1 by 1.4, 1 into 4, not 1.4. Okay, don't forget. 1 by 1 into 4, 1 by 4 into 7. Similarly, you have to prove this statement. As usual, step 1 to prove P of 1 is true. So what happens to LHS? Check it. LHS is given by, of what is first term? It is 1 divided by 1 into 4. So this is actually nothing but 4 into 1 is 4. Keep it as it is. Let us check with the RHS. So the RHS is given by 1 divided by, because n is equal to 1, put 3 into 1. So what you will get, 3 into 1 is 3 plus 1. So this is nothing but, again here you are getting 1 by 4. So this proves our step 1. Okay, write the conclusion for step 1. LHS is equal to RHS, therefore P of 1 is true. Fine. Let's move on to the step 2. So step 2, assume P of m is true for some m belongs to n. Okay, so how do you going to write this step? Very simple step. 1 divided by 1 into 4 plus 1 divided by 4 into 7 going on. So last term in LHS is 1 divided by 3m minus 2 into 3m plus 1. Is it clear? Make sure this denominator is, it is 1 divided by. So this is nothing but m divided by 3m plus 1. So this will give me equation star. So nothing to do with step 2. Let's move on to the step 3. And we all know the step 3 is to prove P of m plus 1 is true. So how we are going to prove? Please be very careful with this step. You have to add, what is the term you are going to add? 3 into, wherever you have m in terms, in last term in LHS, remember? So 3 into m plus 1 minus 2 into 3 into m plus 1 plus 1. This is the term you are going to add. See what happens this. So it is 1 divided by 3m. Okay, 3 into 1 is 3. 3 minus 2 is what? 1. So it is 3m plus 1 into 3m. Okay, 3 into 1 is what? 3. 3 plus 1 is 4. So the term you're going to add is 1 divided by 3m plus 1 into 3m plus 4 on both sides of equation star. So what happens if we add the term on both sides? See, it's quite simple. I will get 1 divided by 1 into 4 plus 1 divided by 4 into 7, moving on. 1 divided by, as I told you, instead of writing this term, if you write this term, it is understood that this term is added. So 1 divided by 3m plus 1 into 3m plus 4. Okay, so this will be equal to, see what is present in the right hand side. Already I have m divided by 3m plus 1. For this term, I'm going to add, what is the term? 1 divided by 3m plus 1 into 3m plus 4. Okay, so this is the term I have added. So see what happens in both the terms. I have 1 divided by 3m plus 1 as a common term. See what happens. it is m divided by, it is 1 because only m divided by 3m plus 1 is there. 3m plus 1 in the denominator is taken out, so it is m by 1 plus 1 divided by, it is 3m plus 4. Okay, so let us take the LCM. This is nothing but 1 divided by 3m plus 1 into, if you take the LCM, it is 1 into 3m plus 4, which is 3m plus 4. Cross multiply, 3m into m is 3m square, plus 4 into m is 4m, plus 1 into 1 is 1. Okay, so this is nothing but 1 divided by, you have 3m plus 1. Okay, denominator will definitely be 3m plus 4. Now it's up to you. I'm going to give this process up to you. You have to factorize. I will give you the final solution. So if you factorize this term, you will get m plus 1 into 3m plus 1. Okay, I hope you know how to factorize the terms. Once you factorize, this is what you get. Now you can see here, I have denominator 3m plus 1, numerator 3m plus 1. So what is left over? I am left over with m plus 1 divided by 3m plus 4. Okay, this can be further rewritten as m plus 1 divided by, please look carefully here, 3 into m plus 1 plus 1 I'm going to write. If you want, you can check. 3 into m is 3m. 3 into 1 is 3. 3 plus 1 will give me 4. If you want, you can check it carefully. This step will match with my RHS in the last term, but n is replaced by m plus 1. So this will conclude the step 3. Therefore, P of m plus 1 is true. Okay, students, once you can write the final conclusion, this will complete the solution for the given question. Okay, right, students, it's time to wind up the class. Before that, I'll give you one question for you as a homework, the similar one which we have worked now. Okay, in the same way, you can find it out. Okay, so take down the question for the homework. So please take down this step. P of n is 1 by 1 into 2, 1 by 2 into 3, 1 by 3 into 4, so on, 1 divided by n into n plus 1. This should be equal to n divided by n plus 1. Okay, I believe you can easily solve this. In case if you have any doubts in this question, I'm going to give the solution for this in the next video. Well, hope you have understood this session and you don't have any doubts. You can always post your comments in our comments box, so which will allow us to make better videos which would be useful for all the students. Fine. So don't forget to share this video with all of your students, all of your friends. If you have still not subscribed to our channel, don't forget to subscribe it and click the bell button so that you get all the notifications as soon as our videos are released. Well, students, so we'll meet again in the one last session on the chapter of mathematical induction next time. Until then, take care of your health. God bless you all and bye.